Hello everyone, this is Team 16 and our project is AI stock trader based on new sentiments.
So, for our project, the problem we are trying to solve is that the stock market is a dynamic environment where there are many observed and unobserved factors influencing stock prices and trends, which are highly volatile and difficult to predict. We ideally, in addition to price, we need to include a wide range of data to aid our decision making, such as financial reports, news articles, mass sentiments, etc., etc. So, for our project, our solution is such that want to utilize advanced AI and machine learning models to help traders to handle large amounts of data and finding trends difficult to observe directly. For our project, we decided to focus on low frequency day-to-day trading and we did want to use news sentiments data to augment the existing stock prices history for better prediction and better trade strategy optimization.
So after we set our goals, we did some research on the existing approaches in this field, and we found some models that are widely used in this area and some data sets and some advanced techniques. So in conclusion, uh, the AI-driven sentiment analysis improves financial forecasting accuracy and reliability. Next. So, uh, in the methods of labeling new sentiments, we found that fine Feinberg is useful in this in our project, and more detail will be introduced later. And in the trading with sentiments, we found that LSTM model uh, did the best for our data, and more of the details will be introduced in the later too.
And let me introduce our system's overview. And our system is composed of four parts: gathering data, sentiment analysis, price prediction, and trading strategy. Our data sources are Polygon AI, MarketOrgs, and Alpha Vintage. Polygon AI provides us with 2 years news and stock prices. It also provides us with several months of new sentiment labels. MarketOrgs provide us with detailed scores on the news sentiment and news relation with stocks, but also it's only in a limited amount. So we decided to calculate the sentiment ourselves. And these tables are our data. The first is the price table, and the second is the news table. We will use the title, description, and keywords to predict the sentiments. And for the sentiment analysis part, we will use Finbert. Finbert will ingest the finance-related data and output the labels and scores. And our result is shown in this table, which contains sentiment labels and sentiment scores. So why we use Finbert? Finbert is a financial domain-specific NLP model based on BERT. So it's designed to analyze financial texts for tasks like sentiment analysis. And our existing new sentiment data is not enough, so we need to label the sentiment ourselves. And let me explain the types of news data we used. The first one is sentiment, which means positively or negatively impact of a news on a stock. The second is relation, and the third is the popularity of the news itself. Among these data, we find that the continuous sentiment scores are the most powerful to predict the price's movements. And for the stock prediction part, we generally use a two-layer LSTM model, which ingests new sentiment, previous delta, and the moving average and prices. And it will provide us with the next price delta predicted. And we have verified the relation between sentiments and the price movements in this chart on the left, which shows a moderate but obvious correlation. And for the model selection part, simple machine learning models, we have tried SVD and linear regression, which have good generalization capacity but are not very expressive to learn the intricacies of the stock movements. The complex DNNs like LSTM, on the other hand, can learn the intricacies of price movement, but are prone to overfitting and needs more data to train. And our predicted price delta correlates from 25 to 30% to the real price data. Due to the law of large numbers, this weak correlation can provide us with a higher yield rate as we trade for a lot of time. And next, let's look at the trading strategy. We will, map the predicted price delta to the next day's stock position using a sigmoid function. In real trade, we will have all historical data to train the model and predict the next price. However, in our experiments, we deployed a 20-fold approach, using 95% of the data for training and predicting the price on the rest 5%. Why we need a sigmoid function? If our predicted price delta is 100% correct, we can all in for a positive delta and close a position on a negative delta. However, as the price delta is erroneous, a higher predicted delta only means higher odds for the stock price to rise. Similarly, when selling out is enabled, we will use a arctangent to map the predicted price to a position between -1 to 1. And let me discuss a little about other settings. We will set the average risk-free rate from 2022 to 2024 at a rate of 4%. We also set a trade cost of 0.15%, which includes regulatory cost and the payment for order flow, which is very important because without the setting of the trade cost, the yield rate can seem to be unbelievably high. So finally, let's look at our portfolio allocation. Our stock pool consists of Apple, Microsoft, Google, Meta, and Amazon, which are considered to be promising and stable. For the portfolio strategy, we will calculate the positions of these 5 stocks as well as cash position using a softmax function of predicted deltas. That is, we mostly hold the fastest growing stock, but we will not all in it since our predicted price delta isn't 100% correct. And the graph above shows the yield trend of always holding the stock and our own strategies, which reveals that our own strategies will perform better than the baseline. Also, the graph below shows every day the percentage of each stock we hold. And our results is that our portfolio trading strategy produces an annual yield rate of 130% with a Sharpe ratio of 2.89. As we enable short selling, the results become even better. So for the experiment parts, we have verified the correlation between the sentiment and the price delta, which shows a moderate but stable correlation. As we know, the stock is very volatile, so there is no single factor that can actually domain the stock trend. However, this weak correlation will make a profit due to the large number law. And we also verify the predicted and real price and reveals a clear correlation between them. Our trend accuracy of prediction is 61.1%. Finally, we verified our yield rate and the Sharpe ratio. For a single stock, you can see that our result will constantly be better than always holding the stock or the traditional long short-term strategy. And when we trading the portfolio, our dynamic allocated portfolio will have a Sharpe ratio of 2.89 and an annual yield rate of 130%. And when we enable dynamic allocation and short selling, our Sharpe ratio and annual yield rate will become even better. And now let's welcome Yunhao to give us a demo of visualization.
So now you can see this is our user interface for the stock analysis. And here is the home page, and there are some simple description of each tab, what they do. So if you trust our analysis, you can directly navigate to the portfolio analysis, and we can select the nearest date in our dataset. And you can see at this date, October 29th, you should hold 99.4% of Apple stock and some percent of Amazon and a little of cash. And if you go to the previous date, you can see we suggest to hold some Google, most of Google, some of Microsoft, and some Meta. So if you are a curious guy, you want to see how this stock performed in the past, you can go to the price and yield trend. There's the trend for the price and for the yield rate. This is for the Apple stock, and you can use the drop down button to select another stock. Also, if you want to see how the data we used perform, you can go to the sentiment correlation tab. Here is the correlation plot of sentiment versus real delta and sentiment versus our predicted delta. So you can see this is for Apple, and also you can select another stock. So that's it for the demo.
Thank you.